Okay, problem number 1 from the intro trig. Now, a couple of things I want to point out. I put a triangle and all the stuff there, the 6 trig functions, for convenience. I mean, having to write this over and over again 20 million times is annoying, so I'm just going to just keep erasing and using the same thing over and over again. Now, they're always going to give you the value of one of the 6 trig functions, the trig ratios. So you already got 2 of them for free, because to get his partner, remember the partner of cosine is secant, you do need to memorize the partners. You only need to memorize the sides for sine, cosine, and tangent, but you have to remember the partners and who they go with. So the partner of cosine is secant, and all I have to do is flip that over to get his value. So that's easy peasy. I don't like the way my theta looks there. I gotta fix that. Theta. Now, the cosine, children are happy, or children are horrible. So adjacent hypotenuse. So the adjacent side is 3, and the hypotenuse side is 4. Now, remember, when you do the Pythagorean theorem, there's a reason that I put the A, B, and C on the triangle. You don't have to put them there, because really, A and B don't matter. This is the dude that matters. This C is always that C, right? This side is technically little a, that side is little b, and this side is little c. That's how I introduced it. I said that the side little a goes across from angle A. That would be the side little a, but we have a different name for it now. We call it the opposite side. So if you don't put the hypotenuse in the correct place, the whole problem is completely shot. You have to make sure the C is in the right place. Now, A and B don't matter. If I put 3 here or 3 here, it doesn't matter. But according to my triangle, I should put the B, the B should be 3. And the A is what I'm looking for. But it doesn't matter if you put the 3 here. You'll get it right. But if you put the 3 here and the 4 here, screwed, totally wrong. So you have to be very careful that you identify your hypotenuse right. And then the rest of it's easy. 3 times 3 is 9. 4 times 4 is 16. Subtract the 9. So you get a squared equals 7. 16 minus 9. And you're like, wait a minute. You can't take the square root of 7. Yes, you can. You get radical 7. So your missing side, the opposite side, is radical 7. So then remember, silly old hobo, children are happy, or tangerines or apples, technology or art, whatever. So the sine is the opposite over the hypotenuse. Yay. To do his partner cosecant, we flip that over. The 4 goes up, the radical 7 goes down. Easy peasy. Tangent is opposite adjacent. So OA, TOA, radical 7 over 3. To get his partner cotangent, I flip that over. The 3 goes up, the radical 7 goes down. This is the easy part. Filling in all of this is the simple part. Identifying your 2 sides and putting them in the triangle, figuring out the third one is the real work here. At this point, you just have to be careful. Just read them off right. And then, flip, flip, flip. Make sure you put the names here. I saw some people, they're like, oh, sine equals radical 7 over 4. And then they draw an arrow and just write 4 over radical 7. What the hell is it supposed to be? This is nonsense. I mean, what the hell is 4 over radical 7? It is one of the 6 trig ratios. You must identify which trig ratio it is and say it's equal to. Also, you can't just write, some people just write this down, sin. This is not, this is a word. This is sin. It's sine theta equal. Make sure be precise here. There's things you can write that are fuzzy. So make sure that when you write them out, you write them exactly the way that I have them in the class notes and the way that I'm doing them now. So now I'm going to try to run through the next 2 as quickly as I can. Okay, so number 2. I got lazy. Kept that the same. Even looks the same. So in problem 2, I told you that the sine of theta was 5 over 13. But the sides that go with sine are opposite and hypotenuse. Silly, old, hobo, or so in SOHCAHTOA. I don't use SOHCAHTOA. I use my acronyms. Like I said, I have my own and I will never forget them. That's how I always remember how it goes. So my opposite side is 5. My hypotenuse is 13. Now I want to point out what I said in class. The hypotenuse, the diagonal, the side across from the 90-degree angle is always, without exception, the longest side. So if you had put the 5 here and the 13 here, you have to understand, it's not possible that the diagonal could be 5 and then this other side is 13. The diagonal has to be the longest of the sides. So check this when you draw your triangle. Make sure when you drew your triangle that the diagonal was the longest of the 3 sides. Now, again, I'm going to write my a squared plus b squared equals c squared. This is my important guy. Who is my c? My c is the side that is across angle c. In this case, it's 13. What's my b? Well, I don't have it there. A, it doesn't really matter with the a and the b, but I want to be consistent with how I labeled my triangle. I called my triangle ABC. So this is my side A. This is my side little b, right? There's little a, little b, lowercase. So I want to be consistent. If I'm going to put the ABC on the triangle, I am going to put them in the right place here. I know that that side is little c. It goes across from the big C. It's also my hypotenuse. So 5 times 5 is 25. 13 times 13 is 169. No jokes there. Minus 25. So b squared equals 144. That means that b equals the square root of 144. Lucky for us, 144 happens to be a perfect square. Yay! Free him from jail. Take it out of jail. 12. Nice. We call this a Pythagorean triple. 5, 12, 13, just like 3, 4, 5. There is a right triangle. You'll see it maybe on the quiz, where it's 3, 4, 5. Can you believe it? 9 plus 16 is 25. This is a Pythagorean triple, also special triangle. It's nice when they have no radical. Then you don't have to worry about, oh, it looks nasty when there's all radicals in it. So we have 5, 12, 13. Notice, longest side, smaller, smaller. Now I'm going to read everybody off. First, yay, I was given this. I got that one for free. I also get him for free because all I have to do is flip this over. Remember, the partner assigned is cosecant. Flip him over, 13 over 5. I mean, technically, you get 1/3 of the question without even doing anything. You just take the guy they gave you and flip it over. Now, cosine, remember, children are happy. Tangerines are apples. So cosine goes with the adjacent side over the hypotenuse. So we're going to do 12 over 13. His partner, secant, we flip that over, 13 over 12. I mean, whatever order you want to do this in. Tangent is opposite, adjacent. So we're going to do 5 opposite. Adjacent is 12. And now I'm going to flip that over. It's nice to have the same triangle drawn. Some people will start getting cute with this. They'll draw the triangle this way. They'll put the theta up there. This makes everything really complicated. Yes, that's still the hypotenuse, but it's a lot harder to identify, opposite and adjacent when you have it written like this. Believe it or not, this is the opposite side, and this is the adjacent side. You don't want to do this. You don't want to draw the triangle in a funky, upside down, rotated, flipped way. Make nice, easy, consistent triangle. I'm using the same damn triangle for all 3 problems. This way, it's easy for me to keep track of everything. All right, so now we'll do the third one. Number 3. I gave you that the tangent is equal to 2. Like, what? The hell is 2? What the hell is 2? I mean, tangent, right? Tangerines are apples. Toa. SOHCAHTOA. Tangerines are apples. So tangent is opposite over adjacent, but I just wrote the number 2. And the thing is, I need it to be a fraction. I need it to be opposite adjacent. So the only thing you could do is just put a 1 under it. I mean, how else can you write the number 2 as a fraction? You can write any whole number as a fraction by putting a 1 underneath. 2 divided by 1 is 2. So the opposite side is going to be a 2 now, and the adjacent side is going to be a 1. Yay! Now all I'm missing, again, this one is going to be different than the other two. I know A, right, across from angle A is side A. Across from angle B is side B. I know A is 2. I know B is 1. I don't know C. I don't know my hypotenuse. I don't know it. I need to figure it out. 2 times 2 is 4. 1 times 1 is 1. Now, this is where you got to be careful. You do some crazy shit here. You just do 4 plus 1 is 5. Right? That's what C squared is. Now, take the square root of both sides. I'm going to reverse it in a minute. Right? You have to you have to take the square root. So you get radical 5. So the missing side is radical 5. Yay! So put it in there. Ow. It's important. I need to use that one. So now tangent was 2 over 1. If you want to just write a 2 there, that's fine. But I need to flip this over. I think it's helpful to have the 1 there when you flip this, because when you flip it, the 1 comes up and the 2 comes down. If you want to just put a 2 here, put a 2 there. But I think, again, since I'm flipping, I'm okay with, having the 1 there. Now, sine OH, silly old hobo, or whatever, stupid old hobo. I used to use stupid old hag. Doesn't matter. Children are happy or children are horrible. So sine goes with opposite hypotenuse. Cosine goes with adjacent hypotenuse. Now I need to do my flips. The partner of sine is cosecant, cusk. Flip it over. Get radical 5 over 2. And the partner of cosine is secant, sec. Flip him over. Radical 5 over 1. And again, if you want to just write radical 5, I'm okay with that. You want to make this a 2? Fine. You want to make this radical 5? Fine. But putting the 1 underneath is, it's all good. Whatever you want to write. Okay, so they're the 6 values. I'm going to really quickly just start problem 4 just to show you what you do when I don't give you a sine, a cosine, or a tangent. Remember, we only memorize so, ka, to, wa. We only remember sine, cosine, tan. We don't do the sides for cusk, sec, and cot. All right, we just remember to flip the main 3. So I'll show you what to do real quick for the beginning of 4. Okay, so 4. Now I'm going to point it. I'm not doing it, but I'm going to start it. Now, I give you cusk. It's 3 over 2. I don't know nothing about cusk. You don't know nothing about cusk, but you should know who the partner is. His partner is sine. And I already know that in order to get from the partner to the main dude, I flip. So when I tell you that cusk is 3 over 2, I'm really telling you that sine is 2 over 3. So now I just told you the opposite side and the hypotenuse side. Play the Pythagorean theorem game, get the missing side. I'll tell you it's radical 5. And then read everybody off and just fill it in. So when I give you the partner, flip, right? So the other 3, number 4, 5, and 6, I gave you cusk, sec, and cot. You have to flip those numbers over, then fill in the triangle. Don't try to fill in the triangle with cusk, because you don't know that cusk is hype over op. Why the hell would you know that? You don't know that. You're not supposed to know that. You're supposed to just know that sine is opposite hypotenuse and then flip that over, okay? And that's the end.